everyone. Welcome back to our second series of lectures on compiler design, and this relates to the second phase of compilation, which is your syntax analysis, also commonly known as parsing. Now, in our previous lectures, we have already gone through the first phase of compilation, which is lexical analysis or scanning. In this particular lexical analysis, we identify the tokens or the words of a given language, and this is followed by this lexical analysis is followed by the second phase, which is your syntax analysis or parsing, and that is what we are going to discuss. So parsing, what it does is that it determines the structure of a program or the syntax of a program. So given any language, you have the words of the language and you have the rules of grammar of the languages based on which the sentences of the languages will be formed. So in programming languages also you have the same thing. The tokens are the words of the language, and when you want to form meaningful structure of your program, then you have to follow the rules of grammar of that particular language so that the words fit together into a given structure. Or in other words, you can say whether the words form correct sentences or not, that is determined during the parsing phase. So the syntax of a language is represented with the use of grammar rules. Now this is true for all languages, whether it is a programming language or not. And in case of programming language, or in case of the parser, the data structure that is used by the parser, it is also known as the parse tree and the syntax tree. So it is a tree kind of structure because we have some kind of a recursion involved, as you will see. Now the sequence of topics for these forthcoming lectures in the second phase of compilation, we will first look at the parsing process. Then we will look at context-free grammar. Now context-free grammar you have already studied in your TOC class, so I am not going to go very much into details. We'll just do a quick recap. Then we will look at the different types of parsings that are available, and then we will look at in detail about the different parsing algorithms. So let us start with the first step, that is the parsing process. So the role of the parser in the compilation phase. So as you know, the scanner or the lexical analyzer takes as input the source program, and based on the regular expression that is fed into the scanner, it will identify the words or the tokens of that particular source program. And if the tokens are not available, it does not match, the words do not match the regular expression, then it will generate some error. Now any token that is identified by the scanner goes to the next phase, that is the parser. So you will find that the scanner and the parser works together. So the scanner will scan the token and give it to the parser. And what the parser will do is that the parser will take the string of tokens given by the scanner and it will try to fit it into the structure of the syntax of the language. It will try to put in and check whether the tokens together form a correct sentence of that language or not. Okay, and how does the parser know what is the correct structure? That is because just like the scanner is fed with the regular expression, the parser is fed with the grammar of the language. The grammar rules of the language is fed to the parser. So it will try to compare the string of tokens with the parser, with the grammar, and then if it is correct, then it will generate the output, which is a parse tree. And if it does not find a match, or if it cannot, if the word tokens do not match the structure, the syntax, then it will give an error. And once it is done with a set of tokens, then it will ask the scanner to return the next token. So get next token, you can think of it as a function which will request the scanner to generate the next set of tokens and give it to the parser. And one thing to remember here is that both the scanner as well as the parser, they interact with the symbol table. scanner will enter data into the symbol table, and the parser may look up the symbol table and make modifications to it. And the output of the parser is, as I have mentioned, it is the parse tree. So if all the tokens passed by the scanner are correct, or that is they form correct sentences of the language, then you will get a correct parse tree. You will get one single parse tree, and that is the output of the parsing phase. Now, how does the grammar of a programming language look like? Now, you have all used the language C. So here is something which looks like a grammar, which looks like a C grammar. Okay, and this format in which it is written, this is known as the BNF format or the Backus-Naur form. So you will find that if you look at it a little closely, you will find that you will be able to identify what it means. Like for the first, say here, grammar rule, it says statement can be either an if statement or it can be a while statement. Okay, I said or because you remember this from the regular expression. So this is an option. So a statement can be an if statement, can be a while statement, or it can be a begin statement, or it can be an assignment statement. Okay, so if it is an if statement, we will find an if statement here. So if statement here. So if this is an if statement, then if statement will have this format. So it starts with the keyword if, so it is given in bold here, followed by a Boolean expression, followed by the keyword then, followed by some other statement, followed again by the keyword else, followed by again another statement. So if a statement is an if statement, then it has to follow this particular structure. If, Boolean expression, then statement, else, another statement. Okay, and then you can see the others are also written in the same format. You can see arithmetic operators, these are arithmetic operators, plus, minus, multiply, divide, compare ops, okay, less than, greater than, okay, all these are there, constants, variables. So this is a kind of a subset of your of a regular programming language. So you'll find the language in the BNF of the grammar of C language in the BNF format. You try to Google this and by Cunningham and Han and Ritchie. So you'll be able to find this. You find the language, the grammar of the C language. Now, for any programming language, usually the grammar is generated or it is represented with the form of a context-free grammar. So context-free grammar is a type of a grammar which is represented. The definition is something like this. It is a 4-tuple, means 4 sets, NTPS. Okay, each of these has a meaning. So N here is a set of non-terminal symbols. I'll explain with an example. Okay. T is the set of terminal symbols. Okay, so T is the set of terminal symbols. So T here corresponds to our alphabet in the lexical analysis. So our sigma, if you can recall, that is our T. Okay, and N here is the set of any other variables that are or symbols that appears in the grammar which are not terminals. Okay, so we have some other variables in the grammar which are used for convenience for representing the grammar. Okay. Then we have P. Now P is the set of rules. So P is the set of rules. These are also known as production rules. Okay, they are called production rules because they are used to produce sentences or correct sentences of that grammar, of that language, of that grammar. So these rules are of this type. It has a left hand side and a right hand side. On the left hand side you will have a non-terminal symbol, a single non-terminal symbol, and on the right hand side you can have a string of both terminals and non-terminals. And out of the set of non-terminal symbols, one symbol will be denoted as the start symbol. So all derivations will start from this symbol S. So this is an example. So you can see it's a 4-tuple. The first set, this is set N. which is the variable s, symbol s. Then you have T, that is the set of terminal symbols. So you have A and B, these are the terminal symbols. And here one point to be noted is that again, non-terminals are usually marked with uppercase letters and terminal symbols are marked with lowercase letters. And then we have the P. P is the set of production, so we have it here. So P derives, so you can see first production rule has S derives, okay, A followed by S followed by A. So this is the left hand side, starts with a single non-terminal symbol, and on the right hand side we have a string of terminals and non-terminals. So this is the first production rule. This is the second production rule. S derives so here you can see S derives B, SB, okay. So this is again another production rule. This is the third production rule. S derives epsilon. Epsilon again has the same meaning as in your what we have seen in our NFA DFA. So this is a grammar of this is an example of a context-free grammar. Similarly, we have here also we have another grammar. So S and A, this has got two non-terminal symbols S and A, and it has two terminal symbols 0 and 1. So you can see S starts with 0 0 followed by another S, or it can start with 1 1 followed by an A. Okay? And A starts with 0 0 followed by A or epsilon. Okay, so this is again these are some examples of context-free grammars. Now you might be wondering as to why context-free grammars only. Why all programming languages are always represented using context-free grammar. Okay, so this is the common representation of syntax. All right, it does not mean that all programming languages are context-free languages. Okay, it always has some kind of semantics which cannot be represented by context-free grammar. So the reason why this context-free grammar is used is because the context-free grammars can define the structural syntax of the language. That means what should be following what. Okay, if I have a if statement, that if statement must start with keyword if followed by boolean expression followed by else and so on. So the structure of the language is, it is very convenient to use context-free grammar to represent the structure of the language. But certain things like semantics, that is the how these certain things are interpreted. Okay, the meaning that cannot be represented clearly using context-free grammar. Say for example, I have an expression A plus B. Okay, now if A and B are integers, then plus means I have to find the sum of A and B. Now if A and B are strings, then I have to do the concatenation of the strings. Okay, so how is this plus going to be interpreted? That cannot be handled by context-free grammar. Similarly, if A is integer and B is a float, then what do I do? What is the result? Should the result be a float or an integer? Okay, how do I convert? How do I convert the type from one type to another type? Okay, all these are semantics of the language. So the semantics cannot be captured by context-free grammar. So what is done is context-free grammar defines the structural syntax of the language, whereas semantics are handled in the next phase of compilation, which is semantic analysis. And you will find when we study semantic analysis, you will see that actually it is the context-free grammars are augmented, more things are added to context-free grammar to incorporate these semantic. So certain semantic actions are added with the production rules to make the program, or to make to incorporate these semantics of the language. Okay, so I hope this is clear why we need context-free grammar. And of course, the most important reason is that to write, somebody will have to write the parsers. So if we are using context-free grammar, then it becomes comparatively easier to write the parsers. Okay, so that is about your context-free grammar. Okay? Now in the next lecture, we will discuss about derivations, language generated by context-free grammars. Okay, and we will continue with our discussions on parsing.